Then let's continue. So we got over the hard part of question 4, which was figuring out the relationship between the r and the h. The fact of this not being a square but a rectangle was the main challenge there. And everything else from that point on, I mean, you have your volume, it's just sketching, sub in h equals 6, and then so on and so forth. I think we got over the hard part of that. So that being the case, we should probably move on to question 5 for this one. Let's see. This one looks to be fairly standard here.
Just double checking which question I'm doing.
5a for this one. So we've got this
cool.
open tank. It'll fold up into some sort of box. And we're trying to find the volume, or the equation of the volume.
Would I be putting my answer in expanded form or factorized?
Either is valid. It'll be easiest if you use the factorized form.
Okay, so 4x times x plus 20 times x plus 42.
X plus. Would it be plus or minus on each of those? Did you take a negative out? Oh, no, you took double negatives out. Yeah. Because that would have... No, if you took the negatives out, it would still have a negative on there, wouldn't it? Pluses.
I just did length, width,
Yeah.
and height, and then took 2 out as a factor.
Yeah, 2 as a factor of both of those individually getting into the
So
4x.
42 plus x. There was no negative.
So,
oh, yes, there was.
so you would have like this initial 40 as like the width, for instance, and you're subtracting 2
Oh,
x's.
it's my, yes, right, yeah, of course.
Yeah, that's where the negative is.
Okay.
But otherwise, yeah, that's totally fine. And that'll make the graph that you have a lot more valid when you have a look at it, or trying to figure out the maximal domain. So given this being tech active, you can just sketch it and then look for that hump that we were talking about earlier. If it was like in a tech-free environment, you would obviously have to use your polynomial methods of sketching, and then that graph would start looking, well, make a lot more sense when you have a look at it. We're kind of doing it in a bit of a different order. They do say sketch it afterwards, but I mean, we have freedom to do it in whatever order makes enough sense.
Would the maximal domain be from 0 non-inclusive to 20 inclusive?
Did you say non-inclusive for 0 but inclusive for 20, or?
Yes.
Yeah, okay. Why the difference, I wonder?
Because you can't have a volume of 0, but you could have a volume of 20.
Okay. So that is correct reasoning. Just double check what's actually on the x-axis. Those 0 and 20 do not actually refer to the volume. They refer to something else.
Oh, it's the but then you couldn't have 20 because the y value would be 0. Yeah, okay,
That's it.
that makes
Yeah.
sense.
So
Yeah.
good reasoning, but looking at the different numbers.
It's not. Yeah, okay.
Yeah. What actually is x in this scenario?
Well, x would be the height.
Yeah, it'll be the height of the box. That's right. Another way to describe that would be how much you're cutting out of the sheet that you start with. So it starts to make sense why you can only cut a certain amount of it. And yeah, totally. So the non-inclusive bit becomes, so this was a little bit more ambiguous. I would have actually accepted either inclusive or non-inclusive in this case. In the actual exam, they'll be more specific, saying that volume has to be greater than 0 to be valid, which is what will typically be the case in an actual VCAR exam. So it's good that you already got that habit. Plotting the graph, I imagine you probably saw that just from plotting it, or?
Yeah.
Yeah, okay, cool. Part D are fairly whatevers. Is it fair enough how you would go about that?
Yeah.
Yeah, cool. Similar here, we're just setting volume and solving for x. That's just a CAS solve. Find maximum capacity. Yeah, why not? We'll play with this one a bit. Part F, what is the actual maximum capacity?
I'm 99% sure I got the wrong answer, but I got 13,098.71.
No, that's fine. Yeah, that's perfectly fine.
Okay.
Yeah, it's so if you think about like your volume being length times width times height, you're multiplying double-digit numbers across each other several times. So it shouldn't be too crazy to get that sort of number. And you can also be relatively confident. Usually in these, it'll be less like find the volume and more about here's the equation and get there. It'll be like a show that question. So that's another way you can be pretty confident with the actual shape of it. So there's a few ways you could have done that. There would have been something like Fmax. You could have used the analyze graph tool on the actual graphing thing. What way do you end up going?
I analyzed the graph, and then earlier on I defined the equation as f of x. So I just did f of 8.54 to get the answer.
Oh, okay, cool. So when you analyze the graph, because you already have it as decimal places in this case, it would have given you an x and a y on the graph already. I believe so, anyway.
Yeah, and it just come up as 1.31 and then with the little e plus 4.
Oh, yes, with
so
the e, yeah, because it's a massive number. So you're like, okay, cool, better be safe. And then doing it on the count, yeah, much better. Yeah, that's a good idea.
Because I've answered based off of the points in tests before and written the wrong number because I've gotten confused. So I just wanted to double check.
Yeah, much better to do it that way. So hang on, how many decimal places of the x did you bring? Was it 2 decimal places?
Yes.
Okay. Is that fine? I'm trying to think of if you want to go 1 over, just to be super certain that the rounding error doesn't come up. What do you have as the last 2 decimal places of the volume?
7.1.
Okay, so that did come out fine. I haven't really looked into exactly whether you want to make sure you're keeping just 2, or if you want to go 1 over just in case. It worked out in this case, but I haven't really seen all
But it
caps.
says find correct to 2 decimal places the maximum
Yeah,
capacity.
so you round your final answer to 2 decimal places, but if you round it early by too much, that does cascade down and cause a rounding error eventually afterwards. I'm pretty sure it's safe to do, like if it says round to 2, then you can be 2 all the way through. I think that's fine, but just on the safe side, I typically will do 3 and then round to 2 at the end.
Did I round my initial? Is it not 8.54 to put in as an X value? Because I didn't get any more decimal places.
Oh, is that just all it was?
Yeah.
Oh, okay,
Because
easy then.
if I did have more, I would typically put in the longer
Oh,
value
yeah,
before
okay, easy.
rounding.
Yeah, I didn't know that was already truncated. So if there was more, you'd bring the whole. Yeah, okay,
Yeah,
that's
yeah.
fine. Yeah, I can only see what they got on the answer sheet right now. But cool, yeah. Yeah, that's that. Now here's one that comes up fairly often as well in an actual exam. So I'm curious if you've seen a question like this before. Let's see how we go. There's a specific trick that you use every time for it. Question 6.
Yeah, no, I've never seen a question like this before.
Okay, well, let's see if you can figure out the trick. I'll zoom in a touch more so that picture is a bit more clear, because observing this picture can help a lot for this one.
Is the area 4x squared?
4x squared is going to be a bit off there. How'd you get 4x squared?
I tried to work out the distance from N to P and then the distance. Oh, wait, hang on. No, I know what I did wrong. One sec. I'm lost, but what I attempted to do was work out the distance from N to P and then the distance from P to Q and then multiply them as length times width. But then I got 2x times the square root of negative y.
Yeah, okay. Um, why m to p as the thing you're multiplying?
N to P because that's, wait,
What
the
did you say?
distance of N to P and then the distance of P to Q
Oh,
multiplied.
n to p. And
Yeah.
yes, okay, that makes more sense. The diagonal seemed a bit weird. Yes, okay. Um, that is fine. Yeah. So basically what you're saying is you want to do length times width, right? You want to figure out what's this distance, which is correct. You've got your 2x there. There's 1x on this side, 1x on this side. That's a total of 2x's. And the width or the height, however you want to look at it, is just going to be y in that case. So the problem that we have is we've got to get it all in terms of x. So there's a trick that you always use in this case. You'll never unsee it. There's an equation right here that puts y in terms of x for you. So you'll be able to use that trick anytime that you have a shape that's inscribed inside of another, like a curve, right? So in this case, you've got a parabola and there's a shape that is touching the boundaries of that curve. Whenever you have that, the points that exist on the shape, usually a rectangle, also exist on that curve. And so because they share the x and the y, you can sort of interchange between the two. So you're going to have your length of 2x and your height of 16 minus x squared, right? Because you're going from 0 to y. Is that clear enough?
I don't understand how you got the height.
The height. So this is on an xy axis right now. So right on the origin on the floor of this is going to be height 0. Right, it's not reached any y value. And whatever this top corner is y.
Oh, that makes sense. And Y equals, okay.
Yeah,
Yeah.
that's it. So wherever that ends up, no matter where you put the x, the y is going to be given by that in terms of x. Yeah, you'll
So
use that all the
it's
time.
negative 2x cubed plus 32x. Can I
2x
expand upon
cubed
that?
plus 30. Yeah, so you could expand it, but again, like kind of like the previous one, you kind of want to keep them in their factorized
Okay.
forms just because it's easier to sketch.
Okay.
Because once you have that, you can very clearly see, oh yeah, 2x means it cuts at the origin, 16 minus x squared, you're going to have cuts at, what's that, plus minus 4, I think. Makes it easier to see what the graph will look like when you then go and get the implied domain.
Yeah.
But yeah, to recap that one, that's the trick you'll use every single time that you have a shape that's inscribed inside of some other curve. The curve equation is important for transforming between the x and y's.
Awesome.
Cool. Okay. And then from here, it's just sort of stuff you've already done. We can fly through it if you like. Do you want to continue with the rest of the B stuff, or are you happy to move on to C?
Let's just do C.
Yeah, sounds fair. So now we're looking at volume. So volume is x by A. A we already know. Oh, okay. So C is also going to be fairly quick, I imagine. So let me know if you want to speed through that one as well.
But with volume, you need length, width, and height.
Yeah.
Okay. So you just multiply the initial equation by x.
Yeah, I mean, that's what they're saying here.
Okay.
X, A. There's no like additional picture for you to have a look at. They've just kind of given it to you.
So it'll be 2x squared times 16x minus x cubed.
Yeah. Yeah. Oh, x squared in the brackets. If you did the brackets, yeah.
Yeah.
So 2x squared bracket 16 minus x squared.
Wouldn't it be by cube? Oh, you're only multiplying the x.
Yeah,
Yes, okay.
yeah.
So it would still be just 16 minus x squared.
Yeah, so it's the exact same thing you had before, but instead of 2x at the front, it's 2x squared.
Okay, that makes sense.
Mm-hmm. Cool. And then this is just, oh, sorry, it's over here. This is just a repeat again. Just what's volume, and then get x, rather than area, and then get x. Okay. Any more of this? Yeah, it's over there a little bit. This is a new fun shape. What have we got here? A garden, rectangle, length y, width is x, and then you've got some quarter circles on either side. Find area of garden, which garden adjoining a wall. So the blue thing here is probably the wall. So garden is going to be the rectangle and the two quarter circles. Okay, that's what's being defined as garden in this case. And we need to find its area. Bit more freedom this time because you get both x and y to work with.
Would the area be x times y times pi x squared over 2?
There should be a plus between those two terms, not a time.
Oh, yes, yeah, there is.
There is.
Yeah.
You just said that. Yeah, you just said it
Yeah,
differently.
yeah.
Easy.
I like my plus was slanted.
Oh, yeah. Sure. Easy enough. Cool. Now for the fun bit where we start having to get terms in terms of each other. So we're given a fixed value for length. So that's going to relate to one of those terms. Get y in terms of x. Yeah, let's just start with that. Y in terms of x.
Would y equal 100 minus pi times x?
Perfect. Yep. Easy done. A in terms of x, I imagine, probably follows almost easier after that. So let's find out.
When it says a, that's not referring to. Is that referring to the area still?
Yeah. So we're told area is going to be A. And so, yeah, just going to be getting the A purely in terms of x now. Which should be fairly trivial, considering there's only one other letter in there, and we've just solved for it.
Would it be a equals negative x times pi times x minus 200 over 2?
Negative x times. Factorization seems, it's a bit different to what I'm looking at. Let me get that one more time.
Negative x times pi times x minus 200, and then all of that over 2.
Negative x, so we're going to have negative x squared pi over 2, that's good. Yeah, and yeah, the x would go in there. Yeah, that's fine. Nice. Okay. And just, I guess, just for fun, the two ways they had that represented was literally just replacing the y with the version and leaving it as that, or expanding it all the way out. Those were the two main ways they did it. But this is fine as well. There's nothing wrong with getting it all over the same term. And then maximal domain. So this is where, depending on which way you do it, it may be easier or harder. You've got the easier way to look at it.
Would it be from 0 to 31.8 both not inclusive?
Possibly. I don't believe this one had decimal places, so if you could get that exact, that'd be ideal. I think you've got it though. Get over pi. Yeah, it's the right number, but you just need to have it in exact.
159 over 5.
159 over 5. It seems a bit... That's a rounded version. So what you're looking for is, well, maybe your CAS only gives 2 decimal places on your thing. Do you?
Yeah, this one only did 1. How would I make that? How would I change that?
So if you go back to the home, we're going to hit the settings in here and document settings number 2. Oh wait, sorry, no, this is for calculator. We'll go to the graphing one, my bad. So back to the graph, menu and settings in here instead. You'll have an option for display digits. What have you got there?
Mine says float 3.
Yeah, float 3. So typically 3 decimal places is what you'll see. Oh, is it 3? It's 3 significant figures, which yeah would mean you're getting the 2 decimal places and then the.
Oh, okay, so if I go back now, I've got quite a few more decimal places.
Yeah, so whatever, I mean, pick whatever of these doesn't completely bloat your screen. You can hit default on it if you want to keep it that way forever. Otherwise, yeah.
Okay.
So yeah, that'll get you more decimal places. That's why I'm always sort of a bit cautious as soon as I see decimal places on the graphing tool, because it can be truncated in those cases. So I'll pretty much just go back to the CAS and calculator tool. Usually use something like an Fmax to get the exact out of it. So if you wanted to get the exact here, you'd still be a bit out of luck, because you do, I mean, this is an irrational number, right? You're not going to get any enough decimal places to get the pi back in it. And so to actually get that, there's a few ways. Any thoughts on how you'd get the exact out of this?
Would you not Like maybe I would have just put the extended number with the decimals in, and my calculator is set to give me a exact answer.
Okay.
But that,
The
wait,
challenge.
how does it work to? Because I wouldn't have gotten that many decimal places.
Yeah. So pi being an irrational number, just like any other root, doesn't actually end as far as number of decimal places goes. So you could float infinity in there. You're obviously not going to be able to. And it's never going to actually get you back to pi. You're just going to get bigger and bigger fractions, getting closer to having the actual thing, but never quite exactly. So to get around that, what you typically are doing is the first option would be just looking at your graph, right? So if I were to sort of try and get a copy of that now, 100x minus pi on 2x squared. Don't fit. Or not, that's fine, don't fit it. I already know where it is anyway. 100, let's go 200 on pi. Wait, what? Did I mess this up? 100x minus pi on 2x squared. Why does it go that far? Should have cut it 100 on pi, not 200. It's a bit weird, unless I'm misunderstanding what I'm supposed to be looking at. Where did your graph end?
As in like
As far as like the horizontal?
where below? Yeah, okay. At it gives it in decimal places, but rounding at like just below 64.
Below 64. Yeah, so about double that. Cool. Okay. So when you got your answer, you were just looking for the peak. Yeah, okay, makes sense. Yeah, this one's, because we're actually dealing with a quadratic, the rules are a little bit different. We're not just looking for the ends of that hump, so to speak. Things are slightly different because now we've got different considerations. So why did you look for the peak there?
Because actually, I'm not insanely. Hang on, I'm going back to my working, trying to work out.
I mean, it's correct to do it. I was just curious what your reasoning was.
It asks for the maximal domain, and that was because that's the highest x value that you'll get.
The highest x.
Like
Well,
the
x is
greatest
horizontal.
x value. Yeah, the greatest x value.
So greatest y would be what you're looking at then if you were
Sorry,
to get all the way
yes.
up to the top. Yeah, so the y in this case is area. So what you're finding is the x value that maximizes area.
Yes.
Maximal domain typically just refers to how many x values. So what's on the x-axis, how far we can go that way.
Oh,
So,
I'm sorry, I did do that. I'm looking at the. Hang on. I'm confused. I have multiple points marked, and now. So when you asked, I already had the endpoint marked, but I put. Why wouldn't you use the index value? Because those are all of the possible x values.
yeah, I mean, that's what I'm trying to consider now, because they had it as this answer, and unless I'm looking at something just different, because I'm looking at, so it's 100x minus pi x squared on 2. 100x minus pi x squared on 2. Yeah, okay. So it's always going to come back to the actual geometry of the shape, what actually makes sense for it. So how big could x possibly be? So we'd have to go back here and have a look at why that's the case. So it's not immediately obvious to me why, which is also kind of why I asked you what your reasoning there was. So let's have a look. We've got length y, width x. What's stopping x from just being infinity? Well, y is related to x. So we need to make sure that whatever x value we choose doesn't force y to be negative. We previously knew that y was 100 minus pi x. So we know that y is always 100 minus pi x. And so you can imagine if we chose an infinitely big x, y is starting to go negative. We don't want to have negative lengths. And so we want to figure out what's the last x value that would give us a valid y. So setting y equals 0 would be the breakpoint on that. And then from here, it probably doesn't take too much imagination to see why you get the 100 on pi instead. So you do your subtraction of 100, divide both by negative pi, you get your x equals 100 on pi for that case.
Okay.
So even though the graph is telling us there are valid area values afterwards, it's the actual geometry of the shape that that is restricting us in that way. It's
Okay,
not
that makes
super,
sense.
yeah, it's not super obvious. It's still the case with the cubics as well, but it's a bit easier with the cubics because you pretty much always get this shape. So if I draw like a really quick rough and dirty one, you get this shape, which is, yep, just look, start, end, like we're already used to. The logic as to why we're doing what we just did is the same reason why we can't consider any of these. It's because we just can't access this part of the graph. We're not allowed to because of the geometry of the actual shape.
Mhm.
So pretty rare, very rare almost, to ever have an issue with this as the parabola. But we found a case where it does become an issue. So that's interesting. Nice.
Awesome. So would it be better to, in the assessment, default to having the equation of y in terms of x to then make y 0?
Better to default to that. Yeah, so I would even chunk it up one step further, which is to say that you want to make sure that all lengths and area, like any quantities that you have in the scenario, are positive.
Mhm.
So you would look at every little quantity. So the y has to be positive, the x has to be positive, and the area has to be positive. That will be all the valid things in this case. If you had volume, you'd have to make sure length, width, height, and volume are all positive for whatever scenario you're looking at.
Awesome.
That'll be like the overarching thing. Now we do have shortcuts, obviously. Whenever you have a cubic, it's always that. Whenever you have a quadratic, I haven't seen too many of those, to be honest, where it's done that. So maybe when you start having quadratics, then you'd have to start worrying a little bit about making sure all the individual things are working out as you expect.
Mhm.
But cool. Okay, that's that one. And then, well, C is kind of whatever. You can do it if you like, just finding, forcing the area to be something and solving for x. But D is probably more important. Up to you.
No, let's skip that one and go to the next.
Sure. All right. So we're forcing a specific height in terms of x. We're forcing a length. Fine. Yeah. Okay. Now we're dealing with volume. So I'd be interested to see if we get the same sort of shape, and maybe if we have an issue afterwards. That'd be weird. Let's find out.
If the length of the fence is 100 meters and that includes the from A to B and then from C to D, what would be considered the width? Or would you
Good.
only would you take the area of the garden and multiply it by the height to work out the volume?
Yeah, that's what you'll typically do.
Okay.
That's like the basic version of any volume, which is area equation and then multiply by height. That is a great question, actually. Yeah. Length of the fence being 100. Because that's got to play a role, surely. Unless it's later on. Overall length. Because you're almost doing perimeter stuff now.
So for the volume, I got negative x squared times pi times x minus 200 over 100.
100. Negative x squared. Double checking them all. Okay. It's factorized a little bit differently in the answer. Have I got what you've written down? Let's make that not blurry. Come on, focus.
Yes.
Yeah, okay. So let's check the pi x term. Negative x cubed pi would be fine. The all over 100.
Did I have it as
Something's
2x squared minus pi times x cubed over 100?
they've got, so it's x squared on 50, and then just the answer we had before. So 100 minus pi x on 2. So it's
Okay.
just trying to, because this 50 in here is the thing that doesn't look like it fits in. Maybe it does, and I'll just say it. It's super easy. 50, it
It,
fits into there as 100, and oh yeah, the 200 can't, yeah. Looks fine.
it makes sense. No, it makes sense how they
Yeah.
did it as well, though.
Yeah, they basically they just sort of kept it as simple as possible, I guess, which is just, hey, you got the same equation that you had before, and then just slap the term onto the end of it,
Mm-hmm.
which is a bit strange why they even bothered to mention the length of the fence.
Yeah.
Oh wait, because it's no, that's why. It's because we had a length of the fence over here that we had to use.
Mm-hmm.
Um, and so yeah, okay,
Just confirming it's the same thing.
yeah,
So then for the volume of soil, would it be 20x?
20x. So for this one,
Because if the area equated to 1,000,
mhm,
you would just multiply that by x on 50.
multiply that by x on 50, yeah. The only challenge is this is no longer in terms of x here, so we do need a specific value, which means we need a term for x as well in this case, which probably came from here. Because you can see they're using the same sort of thing as part C.
Oh,
Find the
okay.
value of x to force 1,000. Now it's 1,000, so it would be whatever you grabbed from this, which we obviously skipped.
Yeah. Okay. Got it.
It's an interesting little sequence of questions, forcing you to go back and use the previous answer, even though they're changing from area to volume.
Yeah.
They did say find it 2 decimal places, and then they gave it to 1 decimal place in the actual answer. Nice. Maybe it does truncate all the way down, but I kind of doubt it.
Let's see their x value. Did they give the exact value or
They gave it to 3 decimal places.
so 51.237?
That's a bit large. You probably did you put it into your volume equation or did you put it back into the old area equation?
I put it back into the area equation.
Okay.
Area
Should be
length.
getting 12.4-ish.
Just a bit off.
Yeah. So the area equation set to 1,000, solve for x. Let's see
Mm-hmm.
what happened.
Oh, now, okay. It came up with two answers when did it, but because it would equate to a negative y, okay, that makes sense.
Or
So 12.425.
yeah, it might not have. Yeah, so it might not have equated to a negative y. It was more so that we have a limit on our domain, right? Like
Yeah,
you got
okay.
31 as the cap from our earlier
Yeah.
question, so we equidistant from that cap. Cool. All right, that gets us that. So yeah, and even if you did use the other answer, it kind of doesn't matter because, well, maybe it does actually. Maybe the volume does change, although I doubt it because they both set area to 1,000. Yeah,
So for the volume of soil needed for a garden with an area of, is that 248.5?
that's it. Yeah,
And
that's
then
it.
would that be meters cubed
Yeah, so that's
with
one thing.
units?
Yeah, I'm going to put meters cubed on that one specifically. Yeah, I was kind of a bit lazy on the other things, although it doesn't look like we. Yeah, you might have needed to put meter squared on the equation.
In
But
the
that kind of
area,
almost
yeah.
confuses things when you put it on an equation.
Mm.
Yeah. Usually you don't give units to an equation, but it does say a meters squared, so I guess you would probably want to do that. Same thing
Yeah.
here, v meters
Mm.
cubed. That one. Um, then this one's just the easier version of that by far. Set value to 500, solve for x. Or I guess solve for all valid x, which it might have a complication in it actually. There's one complication that I can think of that might come up. Give that a shot. May or may not come up.
would, for the third one, the values of x, would it be 18.84?
Yes, it would. Yeah. Did you get a second value?
Yes, I also got 59.11, but if that's outside the maximal domain, do I not include it?
Perfect. Yeah. That's the complication that I thought might come up. So it's good that you spotted it and picked it out.
And the units for that would be
Good question. Let's have a look.
just meters?
Yeah, so we're solving for x, and x is given as meters. Yeah.
Okay.
Nice.
Awesome.
Okay. Let's see how much of 8 we can get done. Probably not going to get all of it, but we'll see. Amount of earth, cross-section of the mound, coordinates. Find the rule of the cubic for this. Okay, that's kind of nasty. You got a bunch of points. What cubic goes through O, A, B, C? No. Definitely want to use a CAS for this one.
Yeah, but would those be considered points of inflection?
No. Let's have a look. So concave down to concave up. I don't know if these would be considered points of inflection, but it does definitely inflect. It's kind of hard to tell exactly when it goes from being concave down to concave up. It does inflect, yeah. Whether or not they're points of inflection doesn't help too much for this, because what you'd be looking for when it comes to solving a graph would be stationary points of inflection when they go perfectly flat, which the cubic will only ever have one anyway. So we can't quite use that to go through it. The hint here is that you're being given 4 separate points to work with. So you're given the origin, you're given A, B, C for all of those points. The idea is that they're all going to eventually be used to get the full equation. You kind of got to do this it's CAS. It's not really the hard way, because you just sort of got to plug in a few equations. Any ideas how you would approach this?
None at all. I'm very lost.
That's fine. So I'll pull up the notes that we had from earlier. Let's see. Polynomials, applications. We looked at it as the worst case scenario of when you have 4 random points on a curve. So obviously this thing doesn't look like a cubic at all, and that's because we just zoomed in on it in a different way. We are told it's a cubic, so what we can do is say, yep, whatever this function is going to be some generic cubic with 4 separate coefficients attached to it. The first step would be in your CAS to define that. So just making sure that you have A, B, C, and D undefined. You would then go through, call the function whatever you want. A times x cubed plus b times x squared plus c times x plus d. If any of those show up as bold when you type them, it means you've already got something assigned there, so we got to get rid of it.
So how would I define the points?
Yes, so first up, have you got this equation?
Yes.
Okay, so when it comes to actually putting in the points, we're essentially putting that in as a sequence of equations. So all these points are just xy pairs. If I sub in x equals -2, I get 7, in this case anyway. In our one, we have the origin, so 0, 0, which means when we go through and do our menu sol system of equations, so for me it's menu 3, 7, 1, we're going to get 4 equations since we have 4 points. We're going to have A, B, C, D. And then we're just plugging in each of these points as equations. So for instance, h of 0 equals 0 would be the first one. Then for the point 10, 1, you would say h of 10 is equal to 1. Then h of 30 is h of 30 is equal to 2. And I'm assuming, without looking, h of 40 is going to be equal to 3, but maybe I'm wrong. Yes, it is. And it's going to give us all our coefficients. And since those are already predetermined to be part of the cubic, that also therefore gives you the cubic.
Okay,
That's fair enough?
Mm-hmm.
Yeah. You'll use that as your unfortunate worst case scenario. It wasn't that bad though. You just define the cubic and then plug in all the points. The real worst case scenario is when you have to do this by hand, which is a sequence of maybe you get lucky with elimination, but I mean, if you're looking at these coefficients, those are not exactly pleasant to work with.
Yeah. Is that likely to have to do something like this by? Okay.
No, by hand, never. I've in an exam never had to do. Maybe not even in Tech Active actually. I don't even think you have to do this Tech Active in an exam. In a SAC, maybe I could imagine that. And in a SAC, maybe you would do like a quadratic in by hand, but I doubt it. That seems a bit weird. Maybe like in earlier years when you're just learning quadratics more or less for the first time. We've been doing quadratics quite a bit in school up until year 11 and 12. I think they sort of just think you understand it enough. So they'll usually just sort of not throw those at you anymore. But yeah, that gets us the equation. Let's see, we've only got a minute left, so I'll just sort of briefly talk about these. For what value of x is the height, a certain value? Well, h is the y-axis, so you're just setting y equals 1.5. That's chill. This is a small cubic, sure. I mean, yeah, 1 over 12,000 for that cubic, for the x cubed term. Consider the quadratic and compare them. I mean, that's an interesting just sort of exploration, which is when you have terms that have really, really tiny coefficients, unless you're really, really far out on x, those aren't really going to contribute much at all. Now, x is cubed, so as you get further out, it will eventually become dominant, very, very slowly, but it will eventually sort of have an impact on the shape. But for small values of x closer to the x-axis, you can imagine, if you have like x equals 1, it's contributing 1 over 12,000, whereas the others are contributing a bit more than that, as far as like the sequence of additions.
Is it like methods in that I'd have to have a proper like report written out that's meant to be formatted in a certain way to compare like when it says consider the quadratic form and then compare the graph of the resulting, is there a proper like sentence structure to answer that?
Not really. This is not something that comes up in a exam or even a SAC, really. To give you an idea, what do they even have in the answer? What did they say? They literally just didn't. They didn't say anything at all. They just graphed it.
Okay.
Well, no, actually, they had one statement. The coefficient x cubed, although small, is clearly influential, which is about as vague as it can get. Like if we pull up the screenshot of what I'm looking at, this is sort of what I'm talking about. For the really small values of x, it's basically the same thing. But then as you get larger and larger, because you're cubing that x value, you can see like this would be like x equals 10-ish over here maybe. 10 cubed gets you to 1,000, so you're already having this sort of drastic effect from it here, whereas lower it just becomes the same graph. So not really accessible, but just for your own understanding of how this works, you would say something to the effect of, for small value of x, it's basically irrelevant. For large values of x, it becomes a dominant term.
Okay.
Cool. And yeah, that'll be about it. Maybe I'll just quickly see if there's anything else left on that, because there really isn't that many questions to have a look at. Is that screen share going to change over? Yes, it is. New point, new graph, so exact same process as earlier, and a piecewise. Yeah, okay, just sketching a piecewise, so that's fine. It teaches you a bit about your transformations, like this is going to be a shift right by 80 and a reflection which I don't know if we saw that when I switched over the screen share. I'll just sort of do that now, just for the fun of it. This, so you get a shift and then a reflect, which is what you're saying there.
Would that be calculator like CAS enabled
Oh,
to
absolutely.
answer that question? Okay.
Yeah. You
So,
wouldn't need it necessarily. You can sort of just look at this and be like, yeah, that is a shift right by 80 and a reflection. But that takes obviously a bit more understanding with the with what those transformations actually look like. That just comes with practice, though. But yeah, no need for that at all. Just CAS it out. Totally fine.
cool.
Cool. All right, that's about it. That's the rest of those. So maybe just finish it off in your own time. Maybe just like right after this, just so you can be confident you're still getting them yourself. And then yeah, I mean that's it for that. We've got new content for next week.
Awesome. Thank you so
Cool.
much.
Take care.